Okay, good evening, grade 10s. How is everybody? Welcome back. So, Zayon, you've just arrived. Kiguano, I don't think I pronounced that correctly. Who else is here? Sihle, welcome back. Anam, Jared, nice to have you with us again. Please get started on the do now. It leads on from what we were doing on Tuesday, where we were working from a diagram and then we were writing down. Oh, is it you, Sam? Oh, okay. All right. I was wondering who that was. And Nzole and Kilebohile, welcome back. Hope everybody's well. And David, welcome back, David. We'll just wait for everybody to arrive. Please get started on the do now if you've just joined us. We're going to write down the values of sine theta, cos theta, and tan theta from the diagram that's been provided. Welcome back, Akila. Nice to have you with us again. And Harry and Tandeka, welcome. Don't know if that's your first time with us, Tandeka, but if it is, then welcome to the grade 10 lesson. Osisa, nice to have you back with us again. Welcome back, Zebo. Okay, grade 10s, it's 5:05. So I've given you sort of 5 minutes to be able to look at this if you joined us at 5 o'clock. And if you're not finished, it doesn't matter. It's not a problem at all. Has anybody, or is anybody willing to volunteer what they wrote down for sine theta? So you can, anybody want to volunteer for sine theta? Okay, so Harry says 1/2. I'm not sure who HWMED is, unless you're using a different phone tonight like Sam. Anam says you wrote -1/2. Okay, so I agree with you. All right, it's -1/2. Okay, so who is that? Harry, you had the right idea. You just didn't look at the sign. Okay. No, that's fine. Doesn't matter. Not the end of the world. Okay. All right. So also we're going to talk a little bit more about this because the terminal arm has come to rest in the third quadrant. That's why X and Y are both negative. But I'm going to talk about that a little bit more this lesson because we didn't see it. We didn't talk about that yet the last time. Okay. Would anybody like to volunteer for cos theta, please?
-3/2.
Okay, so negative root 3 over 2 is perfect, David. Well done. That's really nice. Okay, lovely. And then the last one, tan theta. Is there anybody else who's willing to? Offer an answer.
-1/-3.
Just say that again.
-1/-3.
Negative root 3. Okay, now what would our teachers at school expect us to do if we had a negative over a negative? A negative divided by a negative. Hello, Phoebe. A negative divided by a negative is a positive. Okay, so they would expect us to do that. If we left our answer like this, they might take a mark away from us. Okay, so a negative divided by a negative is a positive. So we would be expected to leave our answer like that, and then it would be in its most simplest form. Okay, is everybody all right with that? No, we're not tipping and turning anything just yet, Sihle. All we're doing is just writing down our ratios from the diagram. So I am going to go through this again. So remember at the end point, we've got a coordinate, all right? So the first value is always the x coordinate. The second value is always the y coordinate. And in this case, they told us that r was equal to 2. So we were just writing sine theta, cos theta, and tan theta based on what we've been given. We will talk a little bit more about how fractions come into play here and where we would use them in this particular lesson. Okay, so we are going to go on to that. All right, so just to recap from Tuesday, right? So I introduced you to shade your rear because x-rays tan your exterior. And I just wanted to remind everybody that's what we're going to be doing again this lesson. We're just going to be doing some sort of slightly more difficult work, or sort of the next thing that leads on the Cartesian plane. But this is really, really important for you, especially in grade 11 and grade 12. Okay, so just a reminder, sine theta is y over r, cos theta is x over r, and tan theta is y over x. Okay, so when we talk about x and y, all right, we are talking about points on the Cartesian plane. All right, so everybody should be aware of what the Cartesian plane is, right? And here is a diagram just to help us a little bit with this explanation. Okay, so the Cartesian plane, whether we are doing functions, whether we are doing analytical geometry, whether we are doing trig, we can take things and we can put them onto the Cartesian plane. We can put graphs onto the Cartesian plane, we can put circles, we can put rectangles, squares, any shape that you can imagine. And of course, in this case, what we've done is we've taken a right angle triangle and we've put it onto the Cartesian plane. So all the Cartesian plane is, right, is it's two number lines that cross over one another. So the horizontal axis, I don't think I'm telling you guys anything that you don't already know yet. The horizontal axis is referred to as the x-axis. Hi, Katlego. The vertical axis is referred to as the y-axis, right? For some reason, I don't know why, but we have decided that we start with 0 degrees over here. And your terminal arm is attached. It's like the hand of a clock, all right? It's attached here at the origin and it swings. So when your terminal arm swings, so it normally would be lying flat like this, And then when we move it upwards like that, if it comes to rest in the first quadrant, all right, it doesn't matter where in the first quadrant it comes to rest. What all X and Y coordinates in the first quadrant share is that they are positive. Okay, so X and Y are both positive in quadrant number 1. Right? Then when we get up here, we get to 90 degrees. Now we're not in quadrant 1 anymore. Now we're in quadrant 2. Okay, so quadrant 2 is always this quadrant over here. And its most notable features are the fact that when we get into this quadrant, X has now changed sign, but Y is still positive. If I was so, in other words, if I came to rest over here, so in other words, my terminal arm has gone all the way here and it's come to rest to the second quadrant. Or I could start again at the very beginning. Let's go pink this time. So imagine if I had a pink terminal arm, and now again, I push the arm up and it goes in an anti-clockwise direction and it comes to rest here in quadrant 3. Then it's done that in an anti-clockwise direction. So now if it comes to rest in quadrant 3, X is still negative, but now Y is also negative. Right, and again, if I was back at the origin, I'm going to try an orange one now, and my terminal arm swung all the way around and it came to rest here in quadrant 4. There's my angle. And in quadrant number 4, my X's are positive, but my Y's are negative. Okay, so this is something that we should know from our study of functions anyway. All right, so in quadrants 1 and 2, so above the x-axis, y is positive, and in quadrants 3 and 4, below the x-axis, y is going to be negative. All right, then in terms of our y-axis, anything to the left of that, so quadrant 2 and quadrant 3, x is negative. And then in quadrant number 1 and number 4, X is going to be positive. So this is really important to us when we start doing trigonometry on the Cartesian plane, because the values of X and Y can change sign. Okay, so they're not always going to be positive. They'll both be positive if we're in quadrant number 1. But if we move into the other quadrants, then the signs of our coordinates can change. Now, R is a distance, r, the hypotenuse, what we used to know it as, okay? The hypotenuse, or r, is the length of the terminal arm, okay? So the hypotenuse of our right-angled triangle. Okay, so because r is a distance, it doesn't matter which quadrant we are in, r will always be positive. Okay, so r is a distance, and as such, it is always positive. Okay, now you're going to learn a lot more about this in grade 11 where they do the cast diagram with you. And then they'll explain to you why the different ratios have got different signs in different quadrants. But we don't really need to know that for grade 10 just yet. So I don't want to dwell on that, but I did want to highlight the difference in the signs of the coordinates with you before we moved on and spoke about the next thing that we were doing today. Does anybody have any questions before I carry on? All okay? Everybody happy with that? Okay, cool. Thanks, Anna. All right, so if we have a look, before we get started on the example, I want us just to have a look at all of the pictures that I've put here. Okay, so there's this one here that I'm just moving up and down. There's this one over here that's number 1, and then there's this one that's over here. Okay, so in this diagram, oopsie, here's my pen. In this diagram over here, so the very first one on the left-hand side where I've put a little purple star, which quadrant are we working in? Phoebe, which quadrant are we in? Where's our terminal arm come to rest? In the first quadrant. Good job. okay? And Anam, in this one over here that now has 2 purple stars, in which quadrant has our terminal arm come to rest? Do you know, Anam? Indeed, the 4th quadrant. Good, lovely, well done. Okay, and then we're going to have a look at this one over here. I haven't got one, a 4th one, but anyway, it doesn't matter. If we're looking at this one over here, David. Okay, so you can tell me in which quadrant is the terminal arm sitting in this one that has the 3 purple stars. Yes, Nizola, that's right. Okay, it's sitting in quadrant number 3. Good, David. Perfect. Okay, so you've got to be very, very careful, grade 10s, all right? I don't know what your particular school will do. It seems as though some schools teach you to find the values of X and Y in other quadrants, which is something that is done in grade 11, and some schools don't. So I'm going to show you how it works, but we're going to keep our examples sort of fairly simple so that hopefully nobody feels too overwhelmed. All right, so if we go and have a look at this first example, over here. Now, this is where you may be doing that tipsing and timesing that you were talking about. Who asked me about tip? Was it you, Sihle? Where you asked me about tip and times, all right? This is a very typical question, all right? So they give you the diagram, all right? There's some information missing, and then they want you to answer questions, all right, based on that, all right? And let's just see. Yes, okay. So this is where your knowledge of working with fractions, so I don't know if you remember when you were in grade 8, you learned how to multiply fractions, you learned how to divide fractions, you learned how to add and subtract fractions. So that was important so that you could do trigonometry here in grade 10. Okay, so all our rules for fractions are important here. Speaking of which, let's just quickly, before we jump in here, let's just recap that. Okay, so when it comes to operations with fractions, we've got different rules, okay? And in my opinion, multiplying fractions is the easiest thing. Can anybody tell me what the rule is when we multiply fractions? Pop it in the chat or unmute your mic. Okay, so you're right, David. When you divide fractions, you end up multiplying. Okay, I'm so glad that you said that, because so many people end up getting confused. Okay, I'm really, really glad you said that. I'm sorry it's wrong, but I'm so glad you brought that up. Okay, so when do we cross multiply? Right? We cross multiply when we are solving for X. So for example, if I've got a question like this, let's say I've got X over 2 equals 3 over, this is not going to work out to be a nice thing. It's okay, Karaba, no problem. Then we're going to cross multiply. So cross multiplying means we're going to say 7 times X is going to give us 7X, 2 times 3 is going to leave us with 6, and then we'd obviously divide both sides by 7, so that would end up being our final answer. Here we are solving, okay? That's when we use cross multiplication. We don't use cross multiplication when we are working with multiplying fractions. So if I give you an example like this, if I've got 2 over 3, and I want to multiply that by 1 over 5, the rule is I multiply numerator with numerator. So 2 times 1 is 2. Denominator with denominator. So 3 times 5 is 50. Okay, does that sound familiar? Is everybody remembering how to do this? Any questions? Phoebe, all happy? Okay. I trust you guys will unmute and talk to me if you have a question. So now when it comes to dividing fractions, okay, so now let's use our same example over here, right? Let's say I've got 2/3 and I want to divide it by 1/5. This is where I've got to use tip and times. Okay, Sihle, so when it comes to dividing fractions, this is where we use tip and times. Or the other thing that your teachers might teach you is keep, flip, change. So KFC, and not Kentucky Fried Chicken, but keep. So keep, flip, change. All right, so if we, yeah, keep, flip, switch. I remember that, absolutely. Okay, I know it is, it's quite a nice one, a nice way of being able to remember this. All right, so what does that mean for us in this example? Well, it means that we keep the first fraction the same because 2/3 is the value that we are operating on. So we're going to keep that the same. Then flip. All right, so flip means flip the sign. Okay, so in other words, the opposite of divide is times. All right, and then switch or change the fraction that follows. So that means what was in the denominator is now in the numerator, and what was in the numerator is now in the denominator. Okay, because dividing 2/3 by 1/5 is the same as multiplying 2/3 with 5. It does the same thing to 2/3. All right, and then again, we follow the rules for multiplication. So we multiply numerator with numerator, and we multiply denominator with denominator. Okay, and we all know that at high school, we're allowed to leave our answers as improper fractions, provided they're fully simplified. So you could leave your answer like that and there wouldn't be a problem. Okay, now I think this is where, is it Mocha? Where did you say that? Where you said cross multiplication, Mocha Malepe. I think this is what a lot of people do in primary school. I don't know, I'm not a primary school teacher, but I think this is what creates the confusion, is because some primary school teachers teach students to add fractions using cross multiplication. And I think that's where the confusion arrives, because it does actually work. But I think it just becomes so confusing with multiplying fractions. So I personally never ever teach it that way. All right, so let's just talk about adding and subtracting fractions. And is there anybody who can tell me what the rule is for adding and subtracting? Does anybody know? No ideas? Okay, so
Ma'am,
yes?
I think you're supposed to get the denominators to be the same.
Quite right, Rebetswe.
Add and subtract.
Indeed, well done. That's perfect. I couldn't have said it better. That's excellent. Okay, so when we add or subtract fractions, we have to have a lowest common denominator. Okay, yes, Phoebe, in LCD, quite right. Okay, so for example, if I have, let's take the same thing, 2/3, and I now want to add 1/5. Right? Our lowest common denominator is often found by multiplying the two denominators together, but sometimes it could be another number that is in both times tables, and the multiplying the two together is not necessarily the smallest LCD. And it doesn't matter if you don't use the smallest LCD, it's not the end of the world, just as long as you always remember to simplify your fraction at the end. Okay, so for example, in this case over here, what I'm going to do is I'm going to create equivalent fractions with the same denominator. So I know that 3 goes into 15. I know that 5 goes into 15. So I need to multiply 3 by 5. I need to multiply 2 by 5. So that would give me 10 out of 15. And over here, I would need to multiply 5 by 3 and 1 by 3. And that would leave me with 3 out of 15. Okay, and then if you guys recall, we're going to keep the denominator and add our numerators, and that would be our final answer. Okay, and then subtracting fractions works in exactly the same way. So if I have got something like 5/7 and I want to subtract a half, all right? Again, I wouldn't be able to do that if I didn't have a lowest common denominator. So in this case, your lowest common denominator would be 14, okay? And then here, you're going to times that by 2 and that by 2. So you'd end up with 10 at the top. Here, times that by 7, times that by 7, minus 7, and that leaves us with 3/14. So again, we would keep the denominator and subtract the one value from the other. Is that okay? Is everybody thumbs up, happy? Good stuff. Okay, so after all of that, okay, let's talk about how it relates to what we're doing here in trigonometry. All right, so who can remember from last time? I showed you something was missing, right? What's missing in this diagram, the one with the one purple star? What's missing? What do we first need before we can even think about answering the questions? What do we have to get?
The y value.
Indeed, and what are we going to use to get the y value?
The Theorem of Pythagoras.
Theorem of Pythagoras. Okay, now you are working in quadrant number 1. All right, so when you solve for y is going to be positive. All right, so now grade 10s, I want you to work out the value of y for me, and I'm going to give you 2 minutes. So using the Theorem of Pythagoras, work out the value of y. Okay, so who has a value for y that they're happy to share? You want to pop it on the chat or unmute yourself? I agree, Masejo. Yes, Maya. I hope I said your name correctly. Is it Maya or Maya? Carabo, good. It is 7.
Maya.
Okay. Maya, okay. All right. Okay, Maya, that's perfect. Yes, so we should have had 7. All right, so Maya's told me, Carabo's told me, and Maseko's told me. Is everybody else okay with where 7 comes from? Do I need to explain that to you, or can we just go on and go and use it? You got 7 too. Perfect. Lovely. Okay. Just so very quickly where it comes from, this is where they're getting their answer from. Remember, Pythagoras is x squared plus y squared equals r squared. Okay, you have to learn that off by heart. Okay, it's very, very important in all parts of math, in lots of different parts of mathematics. Okay, so remember the x coordinate is the one that always comes first, the y coordinate is always the one that comes second, and this 25 represents the length of the terminal arm, OP or R in this case. So we would have said this, 24 squared plus y squared equals 25 squared. You would then do that on your calculator. So what I would do at this point is I would just say 25 squared minus 24 squared. You would then end up with 49, right? Now, when you are taking a square root, right, remember your answer could be positive or it could be negative. But because we are working in quadrant number 1, we are working with positive 7 in this case. All right, so y will be equal to plus minus the square root of 49. Okay, and in this case, y is equal to positive 7. That's where it comes from. So what's nice, I think, is for you to make a little summary for yourself. So over here, you say to yourself, okay, x in this question, x is 24, y is 7, and r is 25. So now you've got x and y and r, and you can write any trig expression that they expect you to. So when we write sine theta, as the question is asking us to over here, let's just pop that in the middle. Okay, so in 5.1, they're asking us to work out what sine theta is. Remember, we've now got to use shade your rear because x-rays tan your exterior. So sine theta is going to be written as y over r. All right, it means y over r. So in this case, it's going to end up being 7 over 25. Does that make sense to everybody? Okay, y over r. So in this case, 7 over 25. Now, I'm just going to move this down a little bit because we've now got to do sine theta over cos theta. So now, what are we doing there? We are dividing fractions, aren't we? All right, so in 5.2, we would end up with what we refer to as a complex fraction. Sine theta, we know, is 7 over 25. So that's this. Now we have to divide that by cos theta. In this situation, what is the value of cos theta? Tsepo, do you know what the value of cos theta is in this case? Okay, so Tsepo's maybe not hearing me. Nasisa, do you know what cos theta is in the case of this diagram that we're working in? What would cos theta be equal to? Excellent. Yes, Phoebe, quite right. It would be equal to 24 out of 25. Okay, so now can you see why you have to know how to divide fractions? All right, because you've now got to simplify this. All right, and most of the time, grade 10s, they want you to do this without the use of a calculator. So in trig, we should really only be using our calculators. I mean, they won't mind if you use your calculator to work out that 25 squared minus 24 squared was 49. They're not going to mind if you do that. But if you go straight from this to an answer without showing any working, you're not going to get all the marks. All right, so we've got to be able to work with fractions. So what does this mean? It means 7 over 25 divided by 24 over 25. All right, so what was the rule when it came to working with fractions? Keep, flip, switch. Okay, so we're going to keep, let's just move the board up a little bit. So we're going to keep the first fraction the same. Okay, we're going to keep it as 7 over 25 because that's the fraction we are operating on. We're going to flip a sign and we're going to switch the next fraction. So the 25 has got to go to the top and the 24 has got to come to the bottom. Okay, now, Mohamolepe, this is another thing where people get confused with cross-multiplying and cross-dividing and all kinds of things. But what we can do here is we can cross-cancel. Okay, so cancelling down means dividing something at the top with something at the bottom. So in other words, 25 goes into itself once, and it goes into itself once over here. And again, we need to know how to multiply fractions to get our answer. Remember, when we multiply fractions, we multiply numerator with numerator, denominator with denominator. Okay, so 7 times 1 is 7, and 1 times 24 is 24. Okay, how does that feel? Thumbs up, thumbs down. How are you guys feeling? Riabetswe, the reason why they are those fractions specifically in this case is because of the information that we've been given. Okay, so if we go back to our original question, all right, we were told here in this diagram that the x-coordinate at P is 24. The y-coordinate, remember, we calculated to be 7 using the theorem of Pythagoras, and the r value is 25. Now, these values change depending on your question. So there's not always going to be 7, 24, 25. They could use any values that they like, to be honest with you. Why didn't we multiply 7 by 25? Because we cancelled. You can, Nozole, you can. If you want to say 7 times 25 and write down the answer, and 25 times 24 and write down the answer, you can do that. But it's much easier, especially if you don't have a calculator. I mean, how easy is it to work out 25 times 7 without a calculator? It's not very easy, is it? So it's easier to cancel down. All right, so if you can cancel down, then it means you don't have to touch your calculator. All right, so that's why. But it would give us the same thing. If you work out 7 times 25, and you divide that by 25 times 24, you'll see your calculator will give you the answer 7 over 24 anyway. Okay, so when it comes to fractions and we're multiplying, either we can cancel down, or if there are no common fractions, no common factors left over, then we wouldn't. So for example, and I know it's always the working, it's not the new stuff, it's always the old stuff like adding and subtracting like terms and working with fractions. These are always the things that get us. So let's say you've got something like this. Let's say you've got 2 over 7 divided by let's say 6 over 14. Okay, so you recognize that you're dividing fractions, right? So you're going to say to yourself, I'm dividing fractions. I've got to keep flip switch. So I'm going to keep 2 over 7 the same. I'm going to flip the sign and I'm going to switch the fraction. Okay, so now, Nzola, if you want to, and other grade 10s, if you want to, you are welcome to say 2 times 14 at the top if you want. No problem with that at all, right? That would leave us with 28. We can say 7 times 6. That leaves us with 42, right? But now we have to simplify. All right, so either you'd have to pick up your calculator, or you'd have to look at the 2 numbers and say to yourself, well, what number can I divide 28 by that I can also divide 42 by? All right, so 28 and 42 are both in the 7 times table. So you could divide the top by 7 and end up with 4, and you could divide the bottom with 7 and you would end up with, actually, there must be a bigger number then, because that's still not fully simplified. 14, okay, it would be 14 actually. All right, so 28 divided by 14, that's what would be our highest common factor in this case, would leave us with 2. And if we divided 42 by 14, that would leave us with 3. All right, or you could do this, okay? If you don't want to do it that way, just write that out. You can do this. And this is what I was doing, okay, Nazole? I was going, 7 goes, let's just use a different color. 7 goes into itself once, and it goes into 14 2 times. 2 goes into itself once, and it goes into 6 3 times. Okay, now I've canceled down. Now I'm going to say 1 times 2 is 2, and 1 times 3 is 3. You see how we get the same answer? Okay, so it doesn't matter which method you prefer to do. I personally prefer to simplify first, but you do whatever works for you. Is that okay? All right, so let's get back. Sorry, because I'm talking and talking and talking, not giving you guys a chance to do much work today. All right, so the next thing that they want us to do is they want us to work out the value of sine squared theta plus cos squared theta. Right? So again, we have to do this by substitution. All right, when they say sine squared theta, they want us to write sine theta as our y over our r, and they want us to square it. Okay, so in 5.3, I'm just going to pop it over here. Sine squared theta plus cos squared theta. They want you to square the ratios. All right, so now you recall from this question, sine theta is 7/25. Remember, guys, when we are substituting, always substitute in brackets. Okay, yes, Phoebe, you must use brackets. Okay, if there's anything that you take away from this tonight, apart from how to work with fractions, you must always use brackets when you substitute. And I'm going to show you quickly when we get to one of the other questions why that is so important. Okay, and then remember cos theta we said was 24/25. And again, they want us to square the ratio. That's what sine squared theta means. Okay, so sub in sine theta, and then you're going to square it. So now you can pick up your calculator, I suppose, if you want to. Not necessary if you know your square numbers. But anyway, if you don't, it's not the end of the world. So 7 squared is 49, 25 squared is 625, 24 squared is 576. You see, if you learn them, it becomes so much easier, over 625. And then again, here we are working with fractions. Are the denominators the same? Yes. So what do? Keep the same denominator and add the numerators. So that gives us 625 over 625. Indeed, Phoebe, the final answer would be 1. Okay, how do you feel? Is that making a little bit more sense now with the fractions, and you can see where it comes in? Okay, good stuff. Everybody else is super quiet this evening. Are you all okay? Are you tired after a long week? All right, let's have a look at this diagram and let's see, maybe this is the only one that we're going to have a chance to work with. All right, I just want to show you something as we first calculate the value. Thanks, Phoebe, I appreciate that. Okay, I hope everybody's all right. Okay, so now let's just have this conversation before you guys try this question. All right, I want to ask you something. If I do this, if I say -4 squared, is that the same as -4 squared? Is that a true statement? Does the left-hand side equal the right-hand side?
No, ma'am.
Quite right. No, you're right. No is the right answer. It does not equal. So in this case over here, -4 squared would leave us with -16, and -4 in brackets squared would leave us with +16. Oh, sorry, Nozole, you were busy writing. There's 5.3 just sitting over there. Okay. And that is why, Phoebe, brackets are so important to use, because remember, my girl, you're not always going to be working in the first quadrant. Okay, so like here, we are working in quadrant number 4. We've got a positive x, fine, but we've got a negative y value. All right, and what we want to do, that looks like 96 instead of 16. My 1 isn't very good, but anyway, never mind. That's supposed to be a 1 grade 10s. You've got to do this, Phoebe, and the others. You've got to do that. Okay. Otherwise, what's going to happen if you put this into your calculator, you are going to end up with a negative number, and your calculator would then end up with 9 minus 16, which would give you a negative value. And then you're going to press the square root, and your calculator is going to have a heart attack, and it's going to tell you that there's a syntax error because you can't take the square root of a negative. So very, 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 the most important thing I've taught you this evening is what to do with the fractions, how to multiply them, divide them, add and subtract them. That's super important. And then if you substitute, it doesn't matter whether you're doing trig, algebra, functions, every section in maths, when you substitute, you put it in brackets and you make sure you put the exponents on the outside. Okay, so now I've done enough talking. I'm sorry. I want you guys to work out the value of R in this question over here. So this is question number 1. All right, R is what's missing. Can you see they've given us the X and the Y? I'm going to give you 1 minute, and you guys are going to calculate the value of R for me, please. Again, if you're stuck, confused, lost, send me a message and I'm sure I will be able to help you.
Ma'am, the answer is 5.
Good, Sam. Okay, you and Maseko got the answer at the same time. Well done. The answer is 5. Lovely. Good job. Okay, so in this case, yes, Phoebe, you got the same thing. All right, so now R was equal to 5. I quite agree. Okay, in this case, X is equal to 3 and Y is equal to -4. All right, so what I'd like you to do based on this diagram, right, I would like you to write down the value of sine theta. I would like you to write down the value of sine theta over cos theta. And then I would like you let's make this a little bit more difficult. I'm going to get you to add tan theta and cos theta. Okay, so you try those 3 questions. Remember, shade your rear, because X-rays tan your exterior. Okay, so now you've got your X, your Y, and your R. You just need to go and sub in. No problem, Ria Betswe. Okay, everybody else carry on. Ria Betswe is just asking me a question here. Again, Ria Betswe, what do you need to use? What are we going to use to get the answer? The theorem of?
Pythagoras.
Pythagoras, indeed. And how does the theorem of Pythagoras go?
X squared plus y squared equals r squared.
Beautiful. Okay, so you've got the X, you've got the Y, sub them in. Remember when you sub into brackets, put exponents on the outside, and then work out the R value. Okay, so I want you to see if you can do that on your own, okay? And then you just tell me how you're doing. No problem, Ria Betswe. Okay, well, what did you get, Phoebe? You can pop it onto the, you got a decimal. No, that's not necessarily wrong. 0,01. Okay, now I don't think that is the right answer. Also, you should have, when it comes to sine theta, you should have got a negative answer. How did you get 0,01? How did you work out sine theta? What did you do? Oh, okay. All right. Remember, remember we're working with X is 3, Y is -4, and R is 5 in this question. Okay, try it again. No problem. Are you calculating an angle, Phoebe? I think that's what you might be doing. All right. So maybe this is, I sometimes say this to the boys that I teach, maybe this is so easy. Maybe it's so easy that it's difficult. Okay. So all you had to do is this, right? Remember, we interpret sine theta as y over r. That's what it means. So in this case, it means take the y, which is -4, and put it over the r, which is 5. That's all it is. Okay, y over r. Okay, you're not, that's it, yeah. That's what's into you. It's so easy, it's difficult. That's all you had to do. All right, so we're not calculating angles. Yes, you see. Okay, so no, you don't, yeah. You see, you don't even need a calculator. Look, see, I haven't got a calculator here with me tonight. Okay. It's a pleasure, absolute pleasure. So Maya says 2,26 for the last one. Okay, so I'm just going to write that over here, Maya. And that was your answer. Anybody else get an answer for 1.2 that they want to share? Okay, so Phoebe says she got -4 over 3. Okay, that's Phoebe.
-4 over 3.
Indeed. Okay, David, 100%. Okay, so Phoebe, David, Nzole, lovely. -4 over 3 is the correct answer for number 1.2. Okay, do you want me to do that question? Do you want me to show you where it comes from? But that is the right answer. Okay, and then I assume if you want me to, you must tell me. And then for tan theta, okay, so Maya, I presume that you went -4 over 3 plus cos theta would have been 3 over 5. Right, now I'm doing this without a calculator, so times by 5 times by 5, so that would be -20 plus 3 all over 15, which leaves us with -17 over 15. So yeah, 2,26 is not the same answer that I get there, Maya. Can you explain how you got the 2.26? Did you do the same thing as me?
Ma'am, I think you
Yes,
forgot to
Sam.
multiply by 3 on 3 over 15. 3 over
But
5.
okay, but isn't 15 the lowest common denominator? Oh, hang on a second.
It's 5.
Hang on a second. Sorry, it's 5. I beg your pardon. Quite right. Sorry, I was already doing it in my head, wasn't I? So it's 3 over 5. Sorry. Quite right. So times by 3 on that side, times by 3 on that side. There we go. Thank you. All right, so that would have given us -20 plus 9, sorry, over 15. Okay, which would leave us, you swap the tan. Okay, it doesn't matter. All right, so that leaves us with -11 over 15. Do you agree? Yes, Nazola, I agree. -11 over 15. Okay, Sam. How's everybody feeling? Thumbs up, thumbs down? Making sense? Good, Phoebe, I'm glad. Thank you. And everybody else, how are you guys feeling? Okay, Sam, good. Thanks, Karabo. Thanks, Tandeka. Well done, Masejo. Okay. These lessons always go way too fast, don't they? Can you believe that we're already at the end of trigonometry? So this was our, thanks, Kelebohila. I'm glad, David. So unfortunately, I am going to have to go now because I've got a lesson with the grade 7s after this. But this, yeah, unfortunately, it's the end of our lesson on trig. The next time I see you guys, we'll be doing analytical geometry. But unfortunately, that's all we've got time for. I think we're going to have to make our trig sessions a little bit longer because there's, still trig graphs and equations and that kind of thing that we still need to do. But at least this gives you a good understanding of the basics. And I've really enjoyed working with all of you. And thank you so much for being such wonderful students. I'm so glad they gave me grade 10s. And yeah, I hope I see you all on the analytical geometry course. Okay, take care, everybody. Bye.
Thanks.
Bye,
Lee.
Tula. Thank you.
Bye.
Bye.
Hello, grade 10s. So before you guys hop off, so as you guys know that we're starting analytical geometry next week, and of course we're anticipating that there's going to be a lot of people that join. We just want to find out how many of you guys, because we want to see if we can open it up to other people. They don't necessarily have to pay maybe for the analytical geometry course. We want to just see how many of you guys have friends that you'd be keen to invite over. So just let me know, maybe with the thumbs up on the comment section on if you guys have any friends that you would want, maybe would send you a link over WhatsApp and you'd forward it to them to just bring them over so they can learn. Maybe someone that you know who can benefit from just joining the analytical geometry course with you. So just let me know, maybe with a thumbs up on the comment section. You guys can do that now before you hop off. Okay, I'm seeing some thumbs up, but I need you guys to do it on the comment. Thank you very much. I'm seeing them now on the comment section, because when you react, they go away. And I actually want to use this data just to know that we do that and then just expect more numbers. Thank you very much. Kilebogile, Tandeka, Anam, Sihle, Akila, Tlafato. I'm gonna open it up for a few more seconds. You guys just let us know. I think it's very important for us to know. So